Hi, I'm Swarupa, course instructor for Geotechnical Engineering 1. In this presentation, we will solve a problem to find lateral force acting due to dry backfill with uniform surcharge. The case considered here is dry backfill with uniform surcharge. The extra loading carried by a retaining structure is known as surcharge. It may be a uniform load, that is the load from roadway, from stacked goods, etc., or a line load, that is for example due to trains running parallel to the structure, or an isolated load may be due to column footing. In the case of a wall retaining a backfill with horizontal surface level with the top of the wall and carrying a uniform surcharge of intensity Q per unit area, the vertical stress at every elevation in the backfill is considered to increase by Q. So lateral pressure has to increase by Ka into Q. Thus, at any depth, sigma h will be equal to Ka into gamma into Z plus Ka into Q. Here we can see a retaining wall of depth h, and it is supporting a cohesionless soil of unit weight gamma. Q is the surcharge which is acting above the backfill. To find the lateral pressure, we need to draw the pressure variation diagram. So first one which is drawn is due to the cohesionless backfill, that is a triangle, and second one is due to surcharge. So at any depth Z, if we want to know what is the pressure, it will be Ka gamma into Z, and due to surcharge it will be Ka into Q. So the base is given by Ka into gamma into H, and due to surcharge it will be Ka into Q itself. So this diagram is called as lateral pressure diagram, and Pa is given by the area of this triangle and the area of rectangle. So this diagram is considered to be a rectangle. So the pressure due to the backfill will be half into base into height. So that is half into base is Ka gamma h and height is h. So it will be half Ka gamma h square. And due to rectangle it will be base into height. So that is Ka_Q into h. Now we will solve a problem based on it. In problem 1, a surcharge load of 30 kN per square meter is acting on the backfill. Determine the total lateral force and its line of action. So here the same problem is considered, wherein the height of the backfill supported by the retaining wall was 3 meter, which was problem number 1. And in addition to it, there is a surcharge load which is acting, and its magnitude is 30 kN per square meter. So we need to find out what is the total lateral force exerted on the wall due to both of these. And also we have to find at what distance that resultant force will act from the base of the retaining wall. Now in problem 1, we already found out that the total active earth force due to the backfill was 24 kN per square meter, and it was acting at a height of 1 meter above the base. So that is what is located here, 24 kN per square meter at a depth of 1 meter above the base of the wall. Now we have to find out what is the lateral force due to surcharge. The lateral force due to surcharge will be base into height, considering it as a rectangle. So base is Ka into Q and height is h. So Ka is already found out in problem 1, that is 0.33 into 30, that is Q which is given, and height is 3 meter. So this will give the value of lateral force as 30 kN per meter, and summation of both these forces, that is 24 plus 30, will be 54 Newton per meter, which is the lateral force. The line of action of the force can be determined by taking the moments about the base. So we will equate the moment due to resultant and moment due to individual forces. So moment due to resultant is 54 into y, considering that it is acting at a depth of y from the base of the wall, which is equal to 24 into 1 plus 30 into 1.5. 1.5 is because for a rectangle, CG will be at h by 2. So 3 by 2 will be 1.5 meter. So we can find y easily, which is 1.28 meter. The thrust due to surcharge acts at a height of h by 2 above the base. So that's why here we had taken 3 by 2, which is equal to 1.5 meter. So now we have found out the total lateral force, which is 54 Newton meter, and it is acting at 1.28 meter from the base of the wall. That is what is the line of action which we had to find. Thank you.